So here we're given this curve, and we're asked to find the relative extremes and the point of inflection. So I'll start with the first derivative, 4x cubed minus 6x squared. I'm going to set that to 0. So 2x squared, 2x minus 3. So possible extremes at x equal to 0 and x equal to 3 over 2. So I'll find the second derivative, and that would be 12x squared minus 12x. I pull out a 12x, x minus 1. And you can see at x equal to 3 over 2, this is negative. Actually, no, it's not negative, it's positive, because this is 1.5 minus 1, which means it's a local minimum. So that's 1 point. And this one, if you notice, this is equal to 0, so we don't really know whether that's the case, whether that's a point of inflection or not. And the condition for point of inflection is that the second derivative is 0. So let's look at when that happens. So that would be the case when x is 0, x equal to 1. Now, to figure out whether this is a relative extreme or not, what I'm going to do is to plug in values around the second derivative and see if it changes sign. So if you look at this expression, I'm looking around x equal to 0. So I'm going to just make up some values. So 0.01 and x equal to minus 0.01. And we can do this qualitatively without actually computing it. So the point here, if I replace that, 0.01 minus 1 would be minus 0.99. Again, you don't have to compute this. Here would be 12 times minus 0.01 minus 1.01, and you'll see that this will become a positive number. This is negative. So there is a change in concavity around x equal to 0. That means it is an inflection point. So x equal to 0 is an inflection point. And so we have so far one extremum. And if you look at the answer choices, actually there's only one that has the one extreme. So it's C. You have two inflection points, x equal to 0 and x equal to 1. And you can do the same thing around x equal to 1. So you can choose 1.01 and 0.99. At 1.01, this would be positive. And 0.99, this would be minus 0.01, this piece here. So again, we have a change in the sign of the second derivative. So therefore, x equal to 1 is also an inflection point. So we have two inflection points and one relative extremum. That's answer choice C. I did make the graph of this function, and you can see it here clearly. Obviously, you don't have access to a graphing calculator, so you can't do that. This is the one extremum at x equal to 3 over 2. And then the two inflection points. This is an inflection point. And then there's another one at x equal to 1. So that's, to recap, the answer is C.